Hi, this is Beth Rosengrant. Today we're going to look at divisibility test. The first thing we're going to talk about is the test for 6. 6 divisible by any number. How do we know? What is the divisibility test for 6 divided by, or divisible by any number? 6 divisible by any number has to be 2 divisible by any number and 3 divisible by any number. So they have to be able to divide, they have to be able to be divisible by 2 and 3. So for example, we can do the number 54. 54, 9 and 6, 2 and 3. So there it's showing 2 and 3. So that is divisible by 6. If we want to see what is the divisibility test for 5. 5 divisible by any number, you are going to look for the last digit has to be a 0 or a 5. Sounds pretty simple. So let's look for a number 20 or 2050. We have 0 as the last digit, so we know it's divisible by 5. 2055 has a 5 at the end, so we know it's divisible by 5. Number 2 is, I found that this one, 17 times 7 equals 119, proves that this statement is not a prime number, because a prime number has exactly 2 factors, and this one has 17, 7, 1, and 119. That's more than 2 factors, which makes it a composite number. Now we're supposed to write or find an example of both of a greatest common and a longest or least common. And I found this one that is 2 neon signs are turned on at the same time, and the other side, oh no, that's not the one I wanted. We're talking about this one up here. Sarah has 16 red flowers and 24 yellow flowers. She wanted to make a bouquet with the same number of each color flower in each bouquet. What is the greatest number of the bouquets you can make? We can see that this says greatest number. So we know we're going to be looking for our greatest common denominator. So you look at these 2 numbers, 16 and 24. Now we're going to find the factors of 16 and 24. I did the rainbow method to see how many factors, and then I brought them over here to our diagram and showed the ones in the middle that are the same, and then found the greatest. So the greatest is 8. So that would mean the greatest number of bouquets she can make is 8. Now we're going to look at the least common multiple, and I found this problem. Paula and Ricardo are serving cupcakes at a school party. If they arrange the cupcakes in rows of 2, 3, 4, and 5, and they always have one exactly left over, what is the smallest number of cupcakes they could have? What the smallest number indicates to us that we are looking for least common multiple. So then we have to look for the least common multiple in all 4 of these. Your greatest, the easiest method to do it is start with the larger number, because here you could go on for days until you even meet this one. So we started with 5, and notice that 4 and 3, so that the greatest common, or the least common multiple is 60, but it also says with 1 cupcake left over, so we needed to add 1. So it's 61. The next problem is the number 1 prime or composite? And the answer is neither. 1 is not a prime number because it only has 1 factor, 1. And a composite number has more than 2 factors, and 1 does not. 1 only has 1. The next question is what are the factors of 12? What are the factors of 12? And I'm going to do the rainbow again. 1 and 2, 12, 2 and 6, 3 and 4. And those are our factors. So we got 1, 2, 3, 4, 6, and 2. What are multiples of 12? That is our 12 times 1, 12. 12 times 2, 24. 12 times 3, 36, and on and on and on. It's 36, 48, 60, 72, 84, 96, 108 to 120. Every counting number has more multiples than factors. That is correct, because when we're looking at the factors of 12, we only had these. But when you're looking at multiples, that means you're going to do all of the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it definitely has more. The next problem is the chip model. The chip model answer is -6 minus 2 equals 4. But we had, when I looked at the chip model, you have 6 negatives and 2 positives. So only 2 can go with the negative away to make it cross out, so that's 4. The problem is -4 is your answer. The number line problem, the problem is 4 plus -6 equals 2. We are going to hop back 6 spots, so that needs your since you're taking a negative number, you have to go backwards. And then we're going to work the following 2 problems and talk about it as we go. So we have the problem, -8 squared plus 10 equals -8 squared. So we are going to find the negative. First thing we're going to do is our exponent. So 8 squared is 8 times 8, 64, plus 10. And would we, so here's the question. When you're taking this, because we know that 8 squared is 8 times 8, is this -8 times -8? Would that make it a negative and a negative equals a positive? That's the question. So then we're going to do 64 plus 10, and the answer is 74. Multiplication does cross out. The next one is the absolute number of 3 plus 8 minus -10. What's that there? -10. So when I said this bracket equals absolute number, and we are looking for -3 plus 8. So -3 plus 8 is the absolute number -5 minus -10. So is the absolute number, I can't remember when we talked about it in class, if the absolute number can't be negative. Can it be negative? Can it be positive? I do know that this is absolute number, but I'm trying to remember. And does negative, like this, yes, that's a negative. 2 negatives equal a positive, but a negative plus a positive is a negative. So that's going to be your -5 minus -10. So the absolute number is where we got to figure out if the absolute number can be negative or if it has to be positive. And then go from there. -10 would be, this is kind of tricky. The absolute number of -5 minus -10. So that's a negative and a negative, which turns into a positive, then a number, then a negative in the front. Subtraction of negatives. -5 minus -10. Well, you get that little negative up here. So I'm going to go with 15 is the answer because negative times a negative. I think that's it.